Good day, everyone. Today, I have a very, very good friend of mine, someone with whom I attended University of Nottingham with. Together, we were classmates, and I was also fortunate to be his project partner in our final year. He is currently a professor, that's what I call him, but his employer might be happy to call him associate professor. That is their own business. But in my own books, he is a professor of mechanical engineering. He studied mechanical engineering from University of Nottingham. After that, he went to King Fahd University of Petroleum and Minerals to start his master's, transferred to Nanyang University in Singapore to complete his master's, and of course, had his PhD from there. He currently teaches at Nottingham University in Malaysia. Without further ado, please welcome, and he's an author. I have to say that he has written 2 books, and my head cannot work around the subject of the book, but all I know is that there is finite element in it, and there's R programming language in it. So there is a bit of computation and all of those in the books he has written. It's going to, of course, we will get to those books when we start to drill into his career and what he has done so far. He has really, really done very well for himself since we left university. And I cannot, overemphasize his achievements in the academia so far. Welcome. Please help me welcome my friend, my brother, Professor Khameel Mustapha. My brother, how are you?
I'm fine. Thank you very much, Engineer Julius Zubair.
Yeah, so, it's been interesting. When we were in the University of Nottingham, I would always think at the back of my mind that, despite you being very academically sound, you looked more like an industry guy than a professor or a teacher that you have become now. So when did you decide to go into academia?
Okay. So thank you very much again for welcoming me onto your platform. It's really, to be frank, it's a pleasure to be here with you, and it's also a delight to be reconnected again after a very long period.
Trust me, the pleasure is all mine. Pleasure is all mine.
Like you said, we did, we were in the university together, and then we did our final year project with Prof together. And it was, it was really a good experience, spending our time during the university days, the permanent site, better by far. So now, coming back to your question, you asked about how I made the transition into full-time academia. Well, actually, the truth is, looking back at the way the story has been written up to this point, I can't really credit a single point or a single factor has been responsible for the transition into full-time academia, but a number of things have contributed. For instance, I think one of the things that I will say first inspire the move to academia is during, I think, in year three, which we call 300 level. So in year 3 or 300 level, then I actually became a member of IMechE, UK's Institution of Mechanical Engineers. So along the way, they usually send to me their professional engineering magazine. Now, anytime I get the magazine, it's very glossy magazine that when you see the cover, you see the content, you just love engineering. But what I love about it is not just the cover page or the the interesting thing they put inside. But what I love generally is, by the time I read the magazine, most of the time I will see that there are a lot of interesting research ideas are emerging at the intersection of mechanical engineering field and some other field, things like nanotechnology, microelectromechanical systems, medical engineering, things that, we actually were not exposed to during our time in engineering. So I could see that, okay, it's like this field is still very interesting. It holds, so much potential. So I wanted to be involved one way or the other in this emerging field. And I feel the only way I can get into it is perhaps to go for my MSc, my master's in engineering. So luckily for me, of course, with those ideas, I also started to look into, getting and going for my postgraduate education. So during my NYSC in Kaduna, then I was actually looking into, applying abroad, sending out applications. So many applications, as things don't come easily. So we send out so many applications, not all of them will be successful. So luckily I got the scholarship to KFUPM for my MSc. So on getting to KFUPM, I see the beauty of academia actually. That was my first contact with high impact research. And our professors were trained in US, majority of them were trained in the US, and they teach with so much passion that also give me that, when you see people teach with passion, you will be, it's contagious. You will also be infected one way or the other. So that is, the beginning of interest into academia. But then I was still thinking that maybe after my PhD, I would still go to industry. But when I go for my PhD in Singapore again, I met so many other fantastic professors that kind of solidify my passion further in academia. And I feel like, okay, I think I will most likely be in academia, but I still, when I finished my PhD, I actually worked in a company in Singapore for a couple of months, but I did not find it interesting. So I actually spent 6 months and I came. So I really did not enjoy it as it would have been if I continue my research studies or my research activities.
That's good explanation, and it gives insight into how you process, things around you. So when you were doing your master's in Saudi, right? You did not particularly complete your master's program in Saudi, did you?
Yeah, actually, I transferred from Saudi
your credit to Singapore.
Exactly, to Singapore. So what happened is 1.5 years into my maybe you haven't completed the question. Have you completed?
No, yeah. I wanted to know why that change,
That change, exactly. So the truth again is, let me say, the dream when I was in KVPM was to complete my MSc. And after my MSc, I wanted to follow the path of the seniors. Usually after the MSc in KVPM, because of their exposure to high impact research, they want to go into USA or Canada, for instance. But I have a very good brother who is from Ibadan. He's Dr. Demola Detunji. Maybe hopefully he will also watch this podcast. And he's a very nice brother. He was actually completing, he's a senior of mine in KFPM. He was completing his own MSc, and he got admission into Canada and was planning to go to Canada. Then he got this notification of a new scholarship by the Singapore government. So the scholarship program was being coordinated by what we call an agency we call A-STAR, which is the Agency for Science, Technology, and Research in Singapore. This is like, the preeminent research body in Singapore. They coordinate all the, the top, R&D programs by the Singapore government. So they put out the call for that scholarship, and he got that information. So he just passed it to me. He said, you might be interested in this. So when I look at the requirement, I see that it is possible for me to make the jump. But I wasn't expecting that I'm going to be successful with the application. So, but anyway, I just said, let me just go for it. And actually kind of, locked me in his room. He said, you have to write the proposal for this scholarship in my office. So I wrote the scholarship there with him. He proved, he go through the proposal, And yeah, he said, okay, then I submitted. And about a month later, I got the call that my application is being reviewed, and I have to be interviewed by a professor from Nanyang Technological University as part of the application process. So I got the call, I did the interview, I waited for a couple of months, and finally I got the final, the outcome that I was selected. So that was very interesting because I was about to complete, but I actually completed the courses that I needed to take in KFUPM, and my performance was very good. But you know, this is I don't want to say.
I trust they have to be.
So yeah, but the performance was very good. So I with that, they saw that, okay, the potential is, I believe they saw that the potential is there. And yeah, they give me the scholarship, which I remain grateful for it. You know, this is a government from the scholarship from the government of Singapore to somebody they did not even know, you know, a small boy from a small village in Nigeria, for instance. And then it was a really eye-opening experience for me, you know, coming from Nigeria. You know, you expect this kind of thing sometimes. You expect things to be on merit, but in Nigeria, as you know, at times, yeah, things will go on merit. At times, it doesn't go on merit. If you don't know people, you may not actually get certain things. But no, this was purely based on merit. They were looking for people that qualify for the scholarship. I applied for. Actually, there were two of us that got the scholarship in that year. That was the beginning to 2008 was the beginning of that scholarship, and two Nigerians. I was among the two. So one of us was in NUS. Myself was in NTU that got the scholarship. So that was the move. The reason why I moved from KWPM to Nanyang, because I saw it as a way to, okay, jump and complete your PhD.
So I'm thinking I've seen most of your papers on Google Scholar, right? And you tend to mostly be looking into material science than what people would think is the mechanical engineering, you know, angle of things. Because I've seen a lot of finite element research. I've seen a lot of micro element research and all of that. So what is your interest in material science? How did you begin to develop interest in towards researching more into materials, you know, as a researcher?
Actually, you know, technically speaking, my research is still within mechanical engineering field itself. Although we have this idea of, mech guys. We have to work with engines, we have to work with, this kind of, hardcore engineering that, we are used to. But when it comes to research, there are different branches of mechanical engineering. So generally, in one aspect, we have pure materials. And another aspect, we have mechanics of materials. And then we have, things like thermofluid. So which combines fluid mechanics and thermodynamics. So this is one aspect. Pure material is one aspect, but my research is actually at the intersection of material and mechanics. So it's mostly mechanics of materials. Now, the reason I kind of situate myself in this area is not maybe because of any specific interest, but the reason is during my PhD, I did a lot of research activities in the area of mechanics of small scale systems. So for these systems, and even for bigger systems in general, you can't do anything without having knowledge of materials. Material, you cannot have a product without materials. even manufacturing. You cannot manufacture anything without having materials. So material is very, very important for product development, for manufacturing, for even if you want to do thermodynamics, at the end of the day, you still have to consider the material you are going to use into it. So what makes material interesting further is that there are always new type of material that will be developed. And when new types of materials are developed, then old questions have to be re-answered again. There are questions that people have answered for the old materials, and then for new material, you have to kind of go back and answer those questions again. And that is also what happened in mechanics. So when you say mechanics of material, although we know mechanics is an old, field or old subfield under mechanical engineering, when you have new type of material, you have to come up with the mechanics of those new type of materials again for, to test what is their properties. If we use them, are they going to be safe? What is their failure characteristics? So all of these kind of characterization, they need to be redone for new types of material. And also when you are going into new type of system that require new type of material, you need to redo this analysis again and again and again. So from my PhD studies, I've been kind of, following this trend to be doing fundamental research at the intersection of material and mechanics.
Wow, that's an awesome explanation, because I'm just envying you. I think I majored in material science, when we were in the university. So I'm just wondering, why is this guy coming to take job from us now? You should leave us to handle this thing and not take our jobs from us. So basically, if you look at your experience as an academia, right, or as an academics rather, in engineering field, and particularly in mechanical engineering, where you have a mix of material and mechanics in your specialty, what would you say is the future of research in mechanical engineering?
That's a very good question, actually, and a very tricky one as well. Because from the position of a I still refer to myself as a young researcher. Like you introduced
we
me
will take that. We will take that. Humility is allowed.
So from the perspective of a young researcher like me, I can see a couple of areas that are emerging. Majorly, I will say two branches. The first branch are still predominantly fundamental research in purely mechanical field. Things like designing with lightweight materials. You are designing with lightweight materials for developing composite material, for instance, material that we call sandwich structures. All of these type of advanced materials, there's still a lot of interesting research that need to be done. They have a lot of application in automotive industry, a lot of application in aerospace industry, and many other areas as well where this kind of material can be used. So designing or lightweight materials, a lot of interesting research are coming up in that. Another area that I also see is manufacturing. We know manufacturing is also an old field, right? In mechanical engineering, we all do lathe machines and milling machines and all that. But nowadays we also have 3D printing, or what we call additive manufacturing generally. So 3D printing is already big, but I still foresee that it's going to be even bigger in the next 5 years. It's going to spread across so many fields, and it's already doing that. I mean, you can find it. In fact, if you type application of 3D printing now, there's almost no field where 3D printing has not been used. From fashion to to pharmacy to medicine. So it's going to even explode further in the next 5 years. Apart from these, we also have areas that are called smart factories and smart manufacturing. These areas will also explode because of Internet of Things, increase in connectivities. As we were talking before before we started now, there will be an increase in connectivity. With increase in connectivities, increase in small devices, increase in Internet of Things, there will also be an explosion of what we call smart factories. So there's going to be a lot of interesting research that will be coming up or will be emerging, already starting, but we'll be seeing, concrete application of these research in coming years. So this is with respect to traditional areas. But we also have the non-traditional areas which involve cross-pollination of ideas from other fields. Where we combine mechanical engineering with medicine, for instance. So you have this biomedical engineering field. So there is also a field called biomechanics. It's not really a new field. It's, there are people that have been working in biomechanics for very long, for the past 30 years, but there's going to be a lot of interest again in coming years. In fact, if you look at high performance athletes nowadays, they are using a lot of, in research coming out of the field of biomechanics. So a lot of interest in that. Sustainability, for instance, electric vehicles. These are areas that require, knowledge of mechanical engineering, knowledge of, mechatronics, E&E, knowledge of materials. So these are some of the, areas that I see, the fundamental, where there will continue to be research in materials, in manufacturing, and in mechanics, but there will also be, the interdisciplinary areas, or what they call transdisciplinary areas, that combine, ideas from multiple fields, but together with mechanical engineering as a component.
Oh wow, that's mouthful. when you said smart manufacturing, yeah, could you put some flesh to that? Could you explain that further? Break it down for us. What is smart manufacturing?
Okay, so smart manufacturing is an idea that revolves around the concept of using Internet of Things, mostly small computers. Small computers are used as the kind of part of the system, but generally the product that is being made, the workers that are working in the company, the production line, and the product that is coming out of the production line. Every single one of those things are connected. There's a hub for all of them. And even when the product leaves the production line, the company can still trace, the health of that product, for instance, or the status of that product, for instance, where it is maybe along the supply chain. And by the time it even gets into the hand of the customers, again, the company, because of the interconnectivity, they will be able to still track, the disposal, or the way it is going to be managed at the end of its life. So you start from raw product in smart manufacturing, in the concept of, in the context of smart manufacturing, you start with raw product. But once the raw product gets into the production line, or it's fit indoor into the company, then the interconnectivity starts. The machines, the non-living thing in the company, together with the living things in the company, together with the product, all of these are going to be interconnected using Internet of Things. So at the heart of smart manufacturing is the use of Internet of Things with portable manufacturing facilities like 3D printers, for instance. And you don't have to be on the factory floor before you can send whatever you want to fabricate. You can just sit in your office, send whatever you want to fabricate via your laptop, and the machine will print it out for you. It will tell you when it is done. You can go and pick it, send to the the next layers within the production line, and from there, the communication flow continues. So it is not a stagnant factory floor, like we have currently. It is a world of internet, just like we have internet, the same idea, but at a factory or let's say, company level interconnectivity, where the product, the personnel, the machines, everything are being controlled, in a well coordinated manner.
Oh, wow. So two things jumped at me while you are explaining this. The first one is that when the product gets to the end user's hand,
yeah,
the manufacturer will still be able to track that product.
Yes, for some of the product. I mean, it may not be
does
for
it
all
mean,
the product.
yeah, does it mean that those products would have some chips embedded in them? Because that sounds scary to me. That sounds scary to me. So if for example, I bought, say, something that doesn't really have to have any electronic chip in it, right? And at the back of my mind, I have to be worrying with the fact that the manufacturer can still trace, for example, a plastic cup. You know, that is scary.
Yeah.
So
yes,
that means,
absolutely.
Yeah. So how possible would that be? You know, I know engineering is awesome. They can find some very small chip and put it there so that they can trace it. And the cost of producing this chip have continually come very cheap, you know. So that can happen, right? So I would want you to, flesh out that concept more. Then the second thing is that, we have about 7 billion people on Earth now. And this concept of smart manufacturing seems to me like when this continue to be the trend and it's, begin to be what most of our manufacturers are looking towards, that means a lot of people cannot get all these factory jobs anymore. So we have to now continually rely on machines and computers to do most of the job that are normally done by people. Correct? So how are we going to be able to now, sustain such imbalance in advancement, right? Technological advancement and the reality of a lot of people losing their jobs.
Yeah, I think this really like the first one is definitely is one of ethics actually, and to be clear on this, I think in the long run this will not apply to many products. If we can categorize product into high end and basic product. Basic product like the cup that I'm using at home, or the water bottle that we are using, plastics. All these basic products may, at the end of the day, it might be actually be costly to put them through that kind of process. But there will be high-end product that actually will definitely not be expensive to be able to trace for many of these manufacturers. Things like our phone. I can tell you most of the phones now, if you are using a Samsung phone, it gets connected back to their database, whether you like it or not. If you are using Xiaomi, for instance, you are using Apple product, it gets connected back. It will ping, the manufacturer back one way or the other, even our laptop. So there are many of these high-end products that are already doing that, and it can be scaled down even further and further and further. But definitely for items that are not mission critical to the manufacturer, they may not actually be interested in tracing what happened to them, but they might be interested in tracing the product until it gets to, say, a middleman, from the manufacturing floor to a client of of the company, for instance, that will now distribute it into go into the mass marketing. So before it does that, maybe they just want to trace the product along the supply chain until it gets into the hand of one of the a client rather than getting into the hand of the the general populace, for instance. So this is one aspect to it. The other aspect which you mentioned now is I don't know if I've cleared the idea of smart manufacturing with the chips that you mentioned. I know that there's a lot of talk about chips, especially with COVID-19, and people are afraid that they can be traced if they get. But this I think it's still far-fetched. With regard to smart manufacturing, there's still a long way to go before many of these things become cheaper. And then I think there will also be a lot of regulations. Government will be able to regulate them and give them, you have to have certain conditions before this can be done. You have to go through this process before this can be done. And just like we're also, still discussing the idea of privacy with Facebook, privacy with Google, there will still be issue of privacy with many of these manufacturing, down the lane later on in the future. But if, for instance, I use my own money and I buy a Samsung smart TV that can be connected to the internet, I can tell you that it's going to be communicating with Samsung.
Yeah, that is why at times you mention a word in your house. Say, for example, you are talking about new laptop. Then you start getting
the
adverts.
Absolutely. Absolutely.
For laptops. Absolutely. So you say these guys are listening to us.
Absolutely.
These guys are listening to us. So the second part of my question was about job. Right.
Correct.
When this smart manufacturing begin to really grow and have strong foot in manufacturing, what happens to those guys, those men and women that we use in our manufacturing floors, to do those jobs? Because that means we are taking some jobs away from these people, right? And I say again, that will create an imbalance.
Correct.
With this big population that we currently have. How are people who are championing this smart manufacturing and all of those big and advanced technologies, how are they, looking into solving the problem of unemployment that might come with it?
Fantastic. Another great question again. And the truth is, frankly speaking, this is one of the shortcomings of we as engineers. So when we, especially, engineers, we only think about what we want to design. We think about the product, we think about the process. But the impact of those things that we are designing on the socio-economic life of the general populace is not within our domain most of the time. And this is what is leading and actually creating a lot of interest in interdisciplinary research, whereby, in fact, in some of the grants that we have to apply for in Malaysia, for instance, if you apply with co-investigators that are all from engineering field, you will not get the grant. For you to get the grant, you need to bring in expertise from those guys from the field of economic, for instance, Faculty of Art and Social Science. So you need to bring in those people that deal with human behaviors, microeconomics, macroeconomics activities. So they will bring their own perspective. So you combine their perspective together, then you can see the significant, what is going to be the impact of this thing that you are designing at the end of the day on the general populace. So people are thinking a lot about this aspect in so many ways, but I still think that some of the thing that will also happen later on, I think we can't shy away from the fact that there will be a lot of upskilling. People that get I don't want to say they get downsized in their company, they might need to, upskill again, retrain for other jobs, because there will be, as some jobs are being taken away, new set of jobs will be coming up. That I think that is the way the technology is playing out. Of course, the guys that will win will be the guys that are designing the system, the guy that is controlling the robot, or that is designing the robot that is automating the production line. Those are the big guys that will win eventually. But there will still be people that will need to control the robot, or that will need to control the factory line. There will still be human contact one way or the other. So like I said, most of these changes will lead to a lot of reskilling or upskilling, or whichever was that we want to use to describe the change that will follow. But yeah, I think we can't really shy away from that fact.
Yeah. Oh, okay. Yeah, good explanation. So for the past 20 months have been very, very difficult for everyone around the globe with this COVID-19 thing. And during my research for this chart, I saw that you and some scholars, you came together to write about, to research into the opportunities that this COVID-19 has brought upon us and the impact it has on sustainability. Could you, share your research process, and particularly your conclusion on that research, of both the impact and the opportunities and the strategic, what did you guys call it? Of COVID, or maybe strategic sustainability strategy, of COVID-19 on going forward.
Yeah, actually, that research was quite a very interesting and challenging research at the same time, because it was, I would say, during the heat of the moment, when we are just getting into into COVID-19. That was when we begin to see, just a few months into COVID-19, somehow all of us in that paper, it includes researchers from, I think, up to 10 different universities. But we've been in touch one way or the other. But you will know Tawfiq Ibn Muhammad, right?
So sure.
He's one. So he's a sustainability guru. So he has been thinking a lot about this, and from my own perspective as well. Materials. There's intersection between what sustainability is about, what I was doing, and also have people that bring economic knowledge, their knowledge of microeconomics, macroeconomics, their knowledge of supply chain. So all of these things, as we were all observing somehow individually, and then the idea started to take root. Before we even brought them together to say, okay, why don't we just put out our thoughts together and then and send it out. So it was a lot of deliberation and observation. As researchers, most of the time we are always kind of observing what is happening. So as you listen to news, you pick up ideas and say, okay, a lot of things are going on around the world. But there seems to be the thread that is connecting all of the different part of the world together is still the idea that this is a once in a lifetime opportunity. COVID-19 is a once in a lifetime opportunity. And, if you don't, when you have ideas and you don't take it out, ideas are perishable. So you have to act on the idea when you have those ideas. And that is what happened. So we had those ideas, we're all thinking about it. Actually, most of us have to kind of leave what other papers or research that we were doing to concentrate on that papers, to pull our resources together. So when we eventually settled down on the title for the research, and then before we started to pull things together, it took a bit of time, because we have to coordinate with some of us, actually some of the researchers that were in UAE, some in the UK, Some of us were in Malaysia and in Japan, for instance. So it took a bit of coordination before we could actually, complete the work, and then we sent it out. But generally, our, the observation that we put in the paper can be centered around the negatives and the positives, and then what each country or globally we should be doing to make sure that we come out of these in a way that will make us resilient. What will make the world or the countries or our locality to be resilient. Okay. So, as you will know, COVID-19 actually has revealed to us that the world is very fragile. We human beings, we are also very fragile. The system we design are fragile. So from these, we can see that it is going to be impossible for the world to actually be healthy if we continue to consume the way we were consuming. So we highlighted the negatives of COVID-19. We know all those things that we know: loss of life, many people lost their jobs. There's a lot of disruption in the tourism industry, disruption in the educational industry. The healthcare system of many of the countries were, under immense strain. Healthcare workers were highly stressed. So all of these negatives were there, but then there's still, the general populace were, generally we're just looking at the negative. But if you look, below the radar, you can still see some positives that are coming out of this. And in fact, some of the reviewers were quite surprised when we listed the positive and said, oh, there's still positive aspect to this thing. Yeah, there's still positive aspect to it. Things like record low CO2 emission, for instance. It's not going to be possible without COVID-19. And what is responsible for that is that many people were sitting at home. People were not driving to work. And there are many countries like India and China, they have also record level of what we call airborne particles, low airborne particles, because the factories, again, were not emitting pollution into the air. So there is cleaner air in the environment. There's also, noise, there's a reduction in noise as well. Again, because people were indoor most of the time. But having listed those positives, we were trying to create a narrative that this positive, by the end of COVID-19, actually we're saying post-COVID-19, and up to now, nobody knows when post-COVID-19 will be, but we were saying that post-COVID-19, it is going to be better if we re-strategize as a species, if we re-strategize the way we approach, the resources of the earth. We have to be more efficient in the way we use resources. Companies generally are kind of, we have become so complacent with the idea of taking from the earth, use it, and dispose it. That is the way we have been operating. And if we continue to do that, then the world will even continue to be more fragile. So our proposal is we have to move towards this circularity, the idea of circular economy, where we don't just take things from the resources, use and dispose them, but you make from it, then we start thinking of how do you reuse those things that you are making. If something happened to them, how do you repair them? How do you refurbish them? How do you remanufacture them rather than just disposing them? So the idea of circularity is to move towards resource efficiency. So when we are designing product, we have to bear this in mind. We have to think about not just designing the product for people to use, but how do you embed circularity within what we are designing? So, and we as engineers, we work within the framework of companies, right? So the bigger company, those guys are thinking of the bottom line, which is profit. So although you are working as an engineer in a bigger company, if everybody thinks along, this circularity thing, then even the profit, the bottom line can actually be very good for many of the companies, because then you are not going to be relying on a resources that you have to get from some other countries. And this is one of also the challenge of COVID, the challenges that COVID-19 brought on many of the countries and companies. They have to get their resources from other countries. With COVID-19, you cannot fly, you cannot travel, you cannot manufacture. But if things are manufactured locally, it's recirculated locally, rather than depending on one country as the manufacturing hub. And that is what is happening now. About 80% of the world is relying on one country as the hub of manufacturing, getting cheap product from that country and relaxing. But when COVID-19, happened, then everybody kind of wake up, say, okay, so we have to do things locally. We have to see how we use our own resources locally, but not just using our resources. How do we use our resources efficiently, to make product? And when we make the product, we should not dispose them just like that. Of course, there will be certain product that we are going to dispose of, but we shouldn't be thinking of disposing every single product that we use. That is the main, the storyline of that paper.
It's interesting that you guys have pointed out that, despite the glooms, that we have seen as a result of COVID-19, there are some positives. And the most interesting one to me is what you said about reduction in carbon emission, right? Because that is actually very easy to see if you are very observant, but I bet not many people thought of that, because most people work from home in the past 18 or so months. And that has actually, added value to the reduction of CO2 emission. So going forward into the future, right? No, before I go there, I've seen that the two books you have written, right? Mostly you use R language to do analysis. And most of us know that in data science, it's either R or Python. And yeah, R is specifically designed for statistical analysis, while Python is more of a general purpose language. So my question is, why do you have preference for R, over Python?
Very, very good observation, actually. So I think I think, as you will know, during my undergraduate, I actually wasn't that much into programming. But then when I went for my PhD in Singapore, to do PhD, sometimes, especially in the kind of work that I did, I need to use a lot of programming. I need to code a number of things myself. So I was exploring a number of programming languages, Python, C, C++, and then finally R. So when I got into R, I don't know, somehow, I used Python for quite a while before I got into R. But somehow when I started using R, I just find it's a very weird language, but very interesting at the same time. It is weird, it has its own weirdness, but it's still very interesting. Once you get into it, it's a beautiful language. So you can do, there are so many packages in R. And the reason, again, maybe I just go gradually. So again, it's weird, but it has a lot of interesting features. And one of the features that make me to love it is many of the people that are using R are academia. In academia, there are professors in many of these big universities in Germany, in Switzerland, Sweden, in US, UK. So if there is an algorithm in statistics today, before it is implemented in any other language, it will have been implemented in R. that is one of the beauties. So because those guys are at the forefront of statistics, and R is considered to be the language of statistics, so they tend to implement algorithms faster in R than in other programming language like Python. So although when I started using it, my interest was purely to use it for the statistics. I need to do some statistical analysis for my PhD. So my interest then in Singapore was to use it for my statistical analysis. But then I keep getting into it. I keep reading more books on R, and I keep developing interest. And just as a hobby, I was writing my finite element code in R. I started writing in Python, but just as a hobby, I started converting those codes into R. So when I converted them into R, they were actually more compact in R. And R has a very beautiful formatting for matrix. Unlike Python, when you display matrix in Python, it still has this weird look, the way it arranged the matrix. And for finite element analysis, we did a lot with matrix. So the way, R display the matrix for me is just very, very good. And then the code that I translated back into R were also very compact. And so I can do so many things in the R environment. Of course, I can do the similar thing in Python, but it's become a lot easier for me to, just continue doing that. And those books that I never intended to write them when I was learning R. It's just by accident. So as I was learning R, and I started converting them into finite element, my code in finite element into R, and then I observed that no one has ever written anything on finite element using R. So I wrote a proposal for the book, and I sent it to the publisher. And it got, when you do something weird, let me put it that way, generally the people that are ahead that haven't used that approach will tend to criticize. So I got a bit of criticism from one of the people that reviewed the book proposal, saying, why is he using R for finite element analysis? But I could see the beauty of doing that. And I've shared some of the code with some of the students as well, and I see that they love it. So I somehow feel that there will be people somewhere that will love to see this kind of thing. And then before I actually send the proposal, I type finite element and R. And I know you will know Stack Exchange. So on Stack Exchange, there was actually a question. Somebody asked a question. Is there any book on finite element with R? So that was another positive point to me that, okay, it seems people are asking for this thing. So why don't I use, my skill in finite element, which is purely mechanical, and then a skill in R, which is not used for mechanical engineering, bringing them together as a unique idea. So the second reviewer was very, he was very impressed with that proposal. The first one wasn't, but anyway, I do understand. He said, I don't think I will use the book. Okay, but the other person or the other professor, also both of them are from the US, said it's an innovative idea, and I do think there will be market for it. And that is how I got, additional validation. At least somebody else also see, the potential in that. So I use that.
So now, how would you say the books, how would you say they are doing so far? What are the feedbacks? The feedback that you have gotten from people, so far.
So far, the two books, like even the second one that I wrote recently, which is actually a short book on R and finite element again, has been downloaded a number of times. And people were asking me for the code. I got a number of emails from researchers from Russia, from China, from Israel asking for the code. So the comment has been fantastic. But another thing about the first one, another thing that that made me happy was some of the first university to acquire the book in their library, like Stanford and MIT. I could find, because I feel I could find that they have these books. And I could see
Awesome.
that my books are in MIT and Stanford and all this.
Awesome. Awesome.
It was
Awesome. Good
amazing.
news. Good news. So
So
a kid listening to this chat, sometimes in the future, and seeing all this impressive achievement that you have done for yourself in academia, and wanting to pursue that path, what would be your advice for that child?
A very difficult question, actually, in a sense. I mean, there's always, okay, this is the thing.
See, I'm asking this because, in this recent past, most people would associate success, with financial, material gains and all of that.
Absolutely.
Right. But anyone who is able to think deep and see the contribution people like you and others that are doing research and, changing technology, bringing new knowledge to the front burner for us to use to better our lives, to change the way we do things in the past. This is a very valuable field that I personally believe we have to continue to feed our best brains, into such fields so that they continue to think our troubles or our problems and prefer solutions to them, right? And yes, there might be just one or two kids out there thinking, I want to also, because when I was growing up, people like Obi, they were my inspiration,
Inspirations, absolutely.
Even Chino Achebe, Wole Soyinka, those guys inspired me.
Yeah, absolutely.
Yeah. Okay.
Absolutely.
And you also are inspiring me because I see what you do, and I've seen amount of effort that you have put into your trade, if I might, call it that, because it is a trade. It is a trade. So, and there's a kid looking at, man, this is a difficult or a challenging field to be. You have to read, you have to do this, but you are doing it and you are very happy with the results you are getting. Okay, so I just want you to, chip in. How, despite all this distraction, around us, how have you been able to stay grounded and to keep your focus and keep pushing, because you are doing awesome job and it is not a sexy job. It is not an easy job, but it is an awesome job. So just from somebody who is there, who is doing it and who is enjoying it, what are those things you can tell anyone who is aiming and looking to be a lecturer or an academic like you? What are the things you think they can do to pursue this and stay grounded?
Yeah, so I think, thanks for all your kind words once again. Generally, I think many people, there are many routes that people have taken into academia. Some get into academia by accident. Some get into it by passion. Some get into it also because they have a mentor that have, taking that same road and they also want to follow the road. But for me, I think it boils down to one thing. I mean, any kid or anybody that is, watching the program and want to also follow the same path. I think the first thing is to believe in yourself. You have to believe in yourself. That is very, very important. In academia, you cannot stay stagnant. If you stay stagnant, you are dead. So, but you have to believe that you can continue to push yourself, to turn up every day and do what is necessary. That belief is the first thing. At times we used to overestimate, say, intelligence and say that, maybe those in academia are intelligent or smart. Yeah, maybe those factors are there. But to me, one thing that I think is important is to have the discipline to turn up every day and do what is necessary. That is the first thing. The second thing is a sense of purpose. To do this job, one must have a sense of purpose. If one is driven purely by money, you will get demotivated. But one has to see beyond that. And for me, I see it as a way, it is one of the few fields or few careers where you can keep inspiring hundreds of kids year in, year out. Every single year, I'm teaching hundreds of students, new students every year, coming to pass through my module, and to see the joy, that they experience when they graduate and send you thank you message, for instance, thank you so much for teaching us. I'm still watching your videos. I'm still reading your notes. All this kind of thing, make it more rewarding. So one has to have a purpose you need to have a purpose. That purpose is the belief that you are contributing to the futures of future engineers. These are future engineers that will be, they will graduate and go on to take on the world, for instance. So that is another aspect to it. The first one I said is believe in yourself, because without that belief, even if you have a purpose, you will kind of still thinking that maybe I can't do it. But you first need to have that belief that I can do it, and then you need to have purpose. And then the third one will be curiosity. You have to be constantly curious. Academia is a field that will stretch your mind constantly. So one has to be, you constantly have to generate stream of ideas regularly. You can't work on the same idea for a very long time. On a regular basis, you need to have stream of ideas. So you need to have a concrete process for generating ideas. But all of these will still go back to that belief that I can do this thing. Then I have a purpose here. The key that I'm teaching, I'm not here just for the money. The money is, at least outside of Nigeria, to be frank, the pay is good for academia. For academia, it's not bad, so to say. So, but again, looking beyond the money aspect, that feeling that you are touching the life of future engineers, it's really, really very rewarding. And then you see them graduating and they are achieving. That also even make us even more happy. Many of my students, for instance, they've gone out to do amazing things, work with big companies, and it just continue to make us happy. But yeah, to be inspired, to follow this same route, just believe in yourself, believe that you can do it, have the discipline to turn up every day, you have, to do the work that is required, and, have a sense of purpose that this is not just about me, it's about, the futures of, the kids that we are teaching as well. And then to have the curiosity to be constantly observing, to be constantly generating ideas. These are some of the skills that are valuable in academia. Yeah.
Oh, awesome! Thank you for that advice. So we should be wrapping up soon, but before then, I want to know, outside all these DYDS, outside all these R, outside all these books, how do you unwind?
How do you unwind? How do you unwind? Yeah, I think, okay, as a family man, I think the number one the number one means of unwinding for me is to spend time with my family, spend time with the kids. They have a way of, just like you said, the Y, the X. Sometimes when they come to my room and they see they see what I'm doing, say, how do you understand all this mathematics? You know, how do you understand all this mathematics? So they're always asking me. So they have a way of disarming us. So when I'm with them, most of the time, if I'm not doing anything, I'm with them. Maybe my son, we go for training on his skateboard. Then my daughter also on his scooter. We just go around the house. And if it is early morning, sometime I like to do that. Just go around, take a walk around the building. Sometimes jog around the building. So exercising is one aspect of it. Spending time with the family is one aspect of it. And there are times you just feel like, I just want to sit down and watch the TV. so, so
It's been an awesome experience, having this chat with you. And I hope that when next we feel the need to bring you and say, Prof, oh yeah, come and tell us this new thing. We hope you'll be able to create time for us. I am very, very grateful for your time, because I know you're a busy man, and you have been able to just share your time with me. This is an awesome moment. This is an important moment to me. Thank you so much, Professor, for having this chat with me.
Thank you very much. I really, it's really a pleasure to be here, to be on this platform. And I'm predicting that it's going to be a very big, very, very big platform.
Thank you, sir.
So I'm serious. I mean, you have a very unique position, actually. Your personality is a very amicable one. You interact with everybody.
Thank you, sir.
I'm serious. So you have a pool of engineering guys outside of engineering as well. That I believe will be lining up to come on the platform. So it's really a pleasure. Thank you very much for inviting me. I think it's a honor for me to be here.
No, all the pleasure is mine, because man, it's interesting that because you're a busy person. I see your work on LinkedIn, and I know you are very, very busy. And for you to just be able to create this time for me, it means a lot. It means a lot to me.
Absolutely.
And by the way, before you go, I have to say this.
Okay.
You might not know, there is somebody that was in Saudi with you.
All right.
Abdul Zubair.
It was my roommate.
Yeah, you asked him about me.
Okay.
Right, and he came on Facebook to add me. Okay. Since then, that was 2007.
Correct.
And since then, we have been friends.
Fantastic.
I can tell you, we contact ourselves almost every week since then.
Every week, absolutely.
Already, he has a way of sending stuff to me. I have a way of sending stuff to him.
Yeah, Abdul is a very, he's a very nice guy. Very, very nice guy, actually. We were in the same room in KFUPM. Actually, the funny thing is, our flight to KFUPM from Qatar to Saudi Arabia, we were on the same flight. But we never knew that we are going to KFUPM together.
Okay.
Until we get there.
Yeah, he added me on Facebook. I was like, who is this Zubair again? Okay, no wala. So I accepted. We became friends, and he told me that
Yeah.
your classmate was my roommate. So he mentioned that you asked him if he knew Jide Zubai, right?
Yes, yes,
Yeah,
yes,
so
yes,
that's
yes.
yeah,
That's amazing.
he's been a good friend. He has been an
Good
awesome
friend.
friend.
Alhamdulillah. Fantastic,
Yeah,
fantastic,
alhamdulillah.
fantastic.
All right, my
That is
regards to Aja and the kids. And
absolutely,
inshallah,
absolutely.
we'll stay in touch. Inshallah.
Inshallah, inshallah,
Jazakallah
inshallah.
khair for your
My
time.
pleasure.
Thank you so much. I appreciate.
My
I mean,
pleasure,
I
my
mean.
pleasure, my pleasure, my pleasure. Okay. Assalamu alaikum.
Why